Before I actually connect the components of the Franklin Bell system here, I'm going to show you 3 pictorials, giving you a little bit of an idea of how it's put together. This Franklin Bell pictorial shows a physical layout of the project, consisting of 2 bells, a pendulum with a hammer, a mounting platform, and a negative ion generator. The 2 bells were purchased from the dollar store and are nothing more than tin candy dishes. The hammer is a dollar store tea leaf container. Those 3 components cost $3 altogether. 2 wooden dowels, about 8 inches apiece in length, 3/8 inch in diameter, and a wooden mounting platform. The dowels are literally glued to the inside of the bells with 1-hour epoxy glue. The wires are soldered to the inside of the bell. Just a hot bead of solder and touch the wire to the hot bead and it's stuck. And the ion generator consists of an outlet box with an item purchased from Goldmine Electronics, which we'll describe and show a picture of in a few minutes, with an on-off switch and a power adapter for the battery. The heart of the negative ion generator consists of this module from Electronic Goldmine. It has 3 wires, PC board with 5 emitters on it, a very small device. The part number is G9695, should you go to the website, and it will run off of anywhere from 9 to 12 volts. And as can be seen in the picture, it has an approximate 15 kV output. Here is the wiring diagram for the Franklin Bell project, and as you can see, it's extremely simplistic. The negative ion generator is encapsulated in epoxy and has all the electronic components that reduce the circuit down to connecting nothing more than 3 wires. There is a 12-volt battery in series with an on-off switch. The black lead is connected to the negative side of the battery from the ion generator. The red side is connected to the positive side of the battery through the switch. And the red side is also connected to one of the bells. There's a heavy-duty insulated red wire and that comes out of the negative ion generator, and that is connected to the negative bell, the bell that will act as the negative electron source or ion source. And that is it. It just doesn't get any easier than this. Okay, we're going to do the fun part right now. We're going to connect the unit up, and very shortly we'll give you a demonstration. We just have these 2 leads here. We're going to remove them. And the first thing we're going to do is connect up the positive bell. And the positive bell is this bell right here. And this coil of wire has no real significance other than it was a way to get rid of some extra length. And I'm going to place that back there. And I'm going to connect the positive bell to the positive connection on the ion generator. Next we're going to do the same thing with the negative bell. This is the negative bell. And we're going to connect the negative bell. Excuse me, we're getting in the way here. And we're going to connect that to the emitters. Just any old emitter. This is going to effectively render the emitter somewhat useless, and it's going to change the bell into an emitter instead. And we're ready to fire this unit up. Okay, here we go. We're going to fire it up and turn on the switch. Watch which way it starts out. Alright, theory of operation. I'm going to turn this off momentarily. We'll come back to watching it. I'm going to discharge the two bells. Got a little tiny shock there. That's a high voltage, very, very low current shock I was receiving, much like a static electricity shock. And here's the theory of operation. When the unit was first turned on, this bell goes to a positive charge, this bell goes to a negative charge. And the pendulum, pretty much neutral. If it has a slight negative charge just from collecting electrons from the air or collecting or being in touch with negative ions, it'll have a negative charge and it will start off and be attracted to the positive bell. If perchance it has a lack of negative charge, ions or electrons, and it has a slightly positive potential, then it will be attracted to the negative bell. So it's pretty hard to tell you which way it's going to go. It really depends on how much charge is on this gong of the pendulum when it first starts out. Once the process is started, as you noticed this last time it went over here, as soon as it touched that positive bell, it picked up all the charge or equal potential as the positive bell had at the time of contact. So you had two units that had equal potential, both positive, and then that bell wanted to run away and get as far away from the positive charge as it could, because following the rule of like charges repel, unlike charges attract. Much like bar magnets and their poles. North and south pole will attract, north and north pole will repel, and the south and south pole will repel. And we have that same principle going on here. So as soon as it touches, it becomes a very positively charged gong, and it wants to run away, and it starts heading right over to the negative bell. And because it's positive itself, it's attracted to the negative bell. So it's not only being pushed from the positive, it's being attracted to the negative. As soon as it makes contact with the negative bell, it picks up the same charge as the negative bell. And now we have the whole situation in reverse. You've got two negatives, and this gong wants to run away. And now it not only wants to run away, it wants to be attracted to the positive bell. And this process goes on and on and on. So, we will start it one more time and let you watch it for a few minutes, or a few seconds. Okay, that is Franklin's bells. A couple of interesting things about Franklin's bells. He originally had his negative bell connected to a lightning rod, and he had his positive bell connected to a ground. And when the potential difference between the upper atmosphere and the ground got significant, his bell would ring. He actually had bells here, and generally it would ring before a thunderstorm. And if you look up Franklin's bells in the encyclopedia, you might get a little more history on his invention. All right, in conclusion, it was my pleasure to show you this little video, and have a very nice day. Goodbye.